We have already seen how arithmetic mean behaves nicely when we change units or add a constant. Well, the same good quality is also shared by median. Let's see how. Suppose that we have measured the lengths of a number of objects in centimeters and show the values along a number line. The median is either the central value in case there is an odd number of points, or a value between the two centralmost values in case of an even number. Now, when you change the unit, say to inches, that is, divide all the values by 2.54, all the values squeeze in by the same factor. The order remains the same, and so does the centralmost value. Thus, the median also gets divided by 2.54. The same thing happens if we multiply or divide by any other constant. Similarly, if you shift all the values by the same amount, the median changes accordingly. So we have this theorem. The median of ax1 plus b etc. up to axn plus b is just the median of the original exercise. You multiply that with a and you add a b at the end. Now let's revisit that example of squares. We had 4 squares and wanted to know the typical side length and also the typical area. We hoped that the typical area would be the square of the typical length. This hope was belied by arithmetic mean. But let's see what happens for median. Let us order the squares by side lengths. The middlemost side length is something between these. Now to find the median of the area, we have to sort the squares by the areas. Since a square with a longer side must also have the larger area, so the ordering remains the same here as well. And since median depends only on the ordering, we can actually talk about a median square as something between these two central squares. The side of that median square is the median side, and the area of that median square is the median area. Since both the median side and median area refer to the same square, the median area must indeed be the square of the median side. In fact, the same thing is true about any transformation that preserves the order. A similar argument also works if the order is completely reversed, because the center of the data will still remain in the center. Because this end would go to that end, and that end would come to this end, but the center stays at the center, and so does the median.